Okay, 1-3, transformations and congruent figures. Transformations. A transformation is a change in a location or a size of a figure. So I have a figure and it
It
moves
just moves
spots.
spots.
Or it changes in size. Okay? Types of transformations are translations, reflections, rotations.
Yep.
Now, who can tell me what a rotation probably is? Oh, good, beautiful. It's where something just kind of spins or moves. It can rotate by 180 degrees, it can rotate by 240 degrees, it can rotate by negative 12 degrees, whatever. Okay, so rotation. Who knows what a reflection would be like? What?
Okay. So it's like this,
Mhm.
and then it like reflects, so it would like that.
Right. Best example also would be you look at your face in a mirror, it's a reflection. Yes? Okay? Who knows what a translation is? What?
We talked about this in math last year. It's when you move the entire thing.
Yes, it's when you shift it. It shifts, it slides,
I used
okay?
that on my
A translation has a slide effect, okay? A rigid motion. A rigid motion is a movement of a figure that produces a figure with the sides of the same length and identical angles. So if something is rigid, that means that the side lengths and the angles are the same measurements. Does that make sense? Okay? It is rigid. Okay? You know somebody that's really rigid? You know what that
Mr.
means?
Gillens.
No.
Oh, possibly, yes.
Yeah.
Okay, so somebody that's really rigid, right, they're like always very consistent, like, okay,
Mr. Gold Senior.
yeah, they have right, you're probably right, he goes to Panera, he comes to school, he goes to Chipotle, right, very rigid
comes
in what he
back.
does.
He goes to an Air
He
Force
yells
School.
at a kid and then.
Oh, yeah.
Okay.
I know the
Stop.
door.
So, rigid motion. Now, a rigid motion does not include a dilation. A dilation is when we multiply something by a whole scale factor, like a scale factor of 2/1, or a scale factor of 1/2, and it changes the size of something. So a rigid motion does not change the side because the side lengths have to be the same amount. Does that make sense? Rigid motion. Rigid motion. Did any of you bring your textbooks to class? Like
I
you
did.
need to?
We're supposed to bring our
Yeah,
textbooks to class?
Definitely.
What? I thought you said that we keep it at home.
You do.
Have it in my locker.
Well, do you have your online
Mine's in the
textbook?
locker. It doesn't
Mine's
work.
in my
locker.
Your online one should work.
Mine doesn't
No,
work.
remember it won't log in for mine.
Yours won't work, so
Can I
yes.
just go back there?
Well, if there's any.
I might have
But I
it.
need you
don't
to
know
turn to
how
pages
mine
for me
works. I have
today.
one in my locker.
Wait,
Yeah,
Guys, focus, let's go. This is chapel schedule. Stop talking and focus.
What page?
I'll tell you in a minute.
It's all fun and games, so it's Travis good.
Page 52-ish, 52 and 53, we're gonna look at some stuff. Okay, we got 10, 8. Okay, rigid motion. Which one of these would be considered rigid motion? Now, when I say which one of these, we are going to look at the black figure, and you are going to tell me which figure is rigid motion.
I know which one it is.
What, Abby?
The orange one?
Why do you think it's the orange one?
Because the angles and sides look the same.
Okay, because they look the same. We can also count units to double check, right? This is 3 units, right? This is also 3 units. This one is 1, 2, 3, 4, that's out. This one is, 1, 2, 3.5-ish, 4-ish, that one's out. What type of rigid motion do you think that would be? What?
A reflection? Or translate, yeah.
Okay, it is, it's a reflection. It's a reflection over the x equals y axis. We'll talk about that later, okay? But I just need you to be able to identify stuff like that. Okay, corresponding sides, corresponding angles have the same or has the same place in two figures. So what that means is this. If I have 2 triangles, we're gonna turn to page 52 and 53, so if you can share with someone, that'd be beautiful. When something's corresponding, it means that that side of whatever you're dealing with matches to a side of another object. So when I have rigid motion and I translate a figure, those sides are always going to match to a side from the original image, okay?
Wait, so is this like a, is this a, what's it called?
No.
Postulate.
No,
What is this?
these are just definitions,
What's that a definition of?
corresponding sides and corresponding angles.
Have the same place too. Okay.
Congruent triangles mean that all sides and all angles correspond, meaning every side of one triangle matches to every side of the other triangle, and every angle of one triangle matches to every angle of the other. They have the exact same measurements, okay? Exact same lengths, exact same angle measurements. So, look at page 52 and 53, because there are pictures I need you to look at for me.
Oh, you had it, thank you.
Page 52 and 53. If there are two, you had to, what,
Can I just grab mine from my-
your book? Grab one from back there. Okay, so page 52 and 53, just, you can share, you don't have to have your own, you can share. It's okay, you won't bite, I promise. That's not, does that look like an algebra book to you? Or a geometry book to you?
You're so smart.
Shut up.
Okay, so page 52, look down at 52, do you see where it says model problem? Okay, we gotta talk through some stuff. See that nice little orange box that says hash marks or arcs? Okay, if you have hash marks, let's say I have two triangles, you're gonna pretend that all these drawings are equal, even though they might not be, okay? If I have a hash mark like this, you should know that those mean that they are the same size group. If I have two, that means that matches to that, this matches to this, yes?
Yes, huh?
Same with angles. If these angles have one like that, that means they are
The
congruent.
same.
If these have two, that means that they are.
The same.
And if this has three, then that means they are.
The same.
Okay? So you need to be able to recognize those hash marks and read those. Cool?
Awesome.
Yeah.
Wait, this.
You did this in 7th grade for sure.
But I don't
No.
draw.
I remember.
Okay? 1 to 1, 2 to 2, 3 to 3. Pretty simple.
Oh, so
Yeah.
if all those are actually triangles, it means that the entire thing is the same.
It means the whole triangle is the same, but if for some reason, let's say I have triangles that are different shapes, right? Let's say I have one that's like this, and then I have one that's like this. But this and this can still be congruent to each other, yes?
Yeah, huh?
Yeah, but those two triangles aren't gonna be congruent,
And angles.
totally, yes. But pieces of them could be congruent to each other, okay? You just need to know how to read that. So, look at that problem. It says determine whether triangles EFD and triangle XYZ are congruent to triangle ABC by rigid motion. Okay? So if we start at triangle EFD, is that triangle congruent to triangle ABC by rigid motion? Why would you say yes?
Yeah,
Because it's rotated.
Because it's rotated, and why else?
Hash mark.
And the hash marks just straight up tell me when I look at it.
Okay, sorry, I meant yes.
It's not reflected, it's rotated.
Isn't it both?
Nope.
No.
False.
It rotated over that axis. If it was reflected, it would reflect so that it was standing the same
Okay.
way, okay? Is triangle EFD congruent by rigid motion to triangle XYZ? No, so is XYZ congruent to ABC? No, okay. Look at page 53. It says, show that triangle ABC is congruent to triangle EFD by rigid motion. Okay? What happened to triangle ABC to get it to triangle EFD? We just talked about that. What happened?
It flipped.
Nope, it didn't
It
flip.
rotated.
It rotated, okay? Those are gonna be hard. You're gonna have to like really study these and kind of pay attention because a lot of times we'll wanna say flip, but it's gonna be a rotation,
I'm
okay?
gonna flip like this way.
I thought it flipped
Looked like
No, it doesn't.
No,
It just
flip.
goes-
If my hand goes like this, flipping it is going like this.
Nope, new terminology.
What?
Now flipping.
Now flipping is literally going over an
I thought that was
axis.
reflection.
It is. Well, flipping goes with reflection.
So the lunar reflection is the same thing.
Yes.
Oh, what?
You
Well, that makes
rotate, you reflect, which is a flip, or you have translation.
Wait, so it's
So can you
rotate.
not
Is
ro-
a rotation a flip? No.
No.
Rotation is when it goes like this.
Yes.
Yeah.
So
Rotation is like this.
it's
It's
a
going
clock.
to have a center point. In this case, the center point is the origin, and it's rotating about the origin is what it's called. So if I took a string to that triangle and tied it to the origin and I rotated it, that's what's happening, okay? Because it's still connected to my origin, it's rotating around the origin, okay? Whew, I know. It's okay. We will start to get it, we just have to be able to see it. One more slide. Congruent triangles, I just have them marked up there for you. Now, how can we, what? Tell me what, I want to know, there are 7 different things that are congruent on these triangles. I need to know one of them. Somebody tell me one. Abby?
The side FB and AB.
Okay, the side FE, is that what you said?
Yeah.
And AB, beautiful. So FE, we would write it this way. FE is congruent to AB. Okay, give me another one.
I thought that would have to be one. Could be an angle.
Angle to
What?
Angle ABC and then FED.
Okay, let's do it, let's make it
Angle B.
easier when you're dealing with a triangle. You said angle ABC, let's just say angle B and angle E.
Got you.
Angle B is congruent to angle E. What else? What?
Line BC is congruent to line ED.
Beautiful. Line BC is congruent to line ED. What else?
Angle D.
Angle D and angle C. Okay, angle C is congruent to angle D. What else?
Angle A is congruent to angle F. I was saying that.
Well, my end is
Okay, angle A to congruent to angle F. What else?
FG and AC.
Segment FE and segment AC.
Wait, no.
And what else?
Segment
B,
BA
A.
and segment EF.
No.
Nope, we already have that.
BC.
Never mind.
BC.
This is kind of a trick
Oh,
question. Abby, you got a guess?
Could you say like triangle ABC is congruent to?
Beautiful.
Smartness.
Triangle ABC is congruent to triangle
I did EFD, but do we have to do it in
FED. Yes, order matters. Listen, if you do not give me exactly the right order, like A, B, C, I went 1, 2, 3, yes? If I don't go 1, 2, 3 over here, it's wrong.
What if it could be 1, 1, 2, 3,
Why though?
1, 2.
Okay, so then, good question, because what if I have like a 45, 45, 90 triangle, right?
Yeah.
Okay, so if I have that, you have to start from the beginning and label which one's congruent to which one. On a 45, 45, 90 triangle, it does make a difference because if these are 45, 45, 90s, right, they're 2 right angles, okay? The
That's
problem
a right
is,
angle?
I can't, yeah, we're
Oh,
gonna,
there's one, right? Just one right angle.
yeah, right there.
Okay, just
Okay.
making sure.
And let's say this is EFD, okay? The problem is this. If I say triangle ABC is congruent to triangle EDF, what's wrong with that?
It's not because they don't have the same center point.
They're not.
Like the
You
right
went
angles
up.
are in the middle.
A and E match, right?
Oh, you're right.
And technically B and D are the same measurement,
But
yes?
they're not the
But
same
no,
angle.
no, no.
They're the same angle, but they're not the same side length,
Right.
Yeah.
okay? So order always matters in geometry.
So would it have to be EDFACB?
Well, it would have to be EFD. Okay, because A corresponds to E, yes? B corresponds to F,
Okay.
and C corresponds to D.
Yeah, that's fine.
So they're trying to trick you with the alphabetical.
Yes, yeah, so you need to pay attention to how you're labeling things, okay? Order matters. If I labeled this segment FB as congruent to segment BA, I would be incorrect. Because F and B do not go together. F and A go together. Okay, and when it tells you on your homework, list all possible congruency of these figures, if it's 2 triangles, you're going to have 7 things. Don't forget the triangles. Okay? That should be what you are working on tonight. Rigid motion and stuff like that. Now listen, on AMSCO.com, if you go to that website,